Question 6. Three 150 ohm light bulbs are connected to a 9-volt battery. Find the current through each one if their bulbs are all in parallel with the battery. So in this case, the voltage drop across every single light bulb will be 9 volts, right? The voltage drop across every one will be the same. So if each bulb has 9 volts across it, and each one has a resistance of 150 ohms, the current is given by V on R, or 9 over 150. That gives us an answer of 0.06A, 0.06 amps. What happens if the bulbs are all in series with the battery? So in this case, the total resistance of the circuit will decrease the current. So the same current flows through each one, and their total resistance is 450 ohms. That's 150 times 3. I equals V on R, substituting 9 volts for V and 450 for R. We end up with 9 over 150, or 0.02 amps. So the light bulbs are dimmer than when they were connected in parallel. Remember that the brightness of a light bulb depends on the current that flows through it. Question 7. A certain type of 100 ohm light bulb can stand up to half 1 amp of current before it burns out. If a set of bulbs is to be connected in series to a 120 volt power supply, how many must be connected to prevent the bulbs from burning out? So if we only connect one bulb in series with the 120 volt power supply, then we have only 100 ohms of resistance, which means we'll get 1.2 amps passing through the single bulb and it will burn out, right? So what we need to do is figure out how many ohms of resistance we need in the circuit to stop the light bulbs from burning out. R equals V on I. And so if we substitute the power source and the maximum possible current, we get a resistance of 240 ohms. So if we have 240 ohms worth of light bulbs, the light bulbs won't burn out. They'll be just on the point of doing that. The thing is, we can't have 2.5 light bulbs. We need a whole number of light bulbs, right? Now, we could round this down to 200 ohms, but if we only put 2 light bulbs in series, then the current through them will be bigger than 0.5, and they will burn out. So we need the smallest number of light bulbs we can get that's bigger than 240 ohms. The answer to that will be 3 bulbs, because 300 ohms is greater than 240 ohms. As long as we have 3 or more light bulbs, the current through all of them will be less than 0.5 amps. Part B. What configuration would maximize the current through 4 bulbs connected to a 120 volt supply without causing them to burn out? Now let's think about this. There are a few different ways that we could wire the circuit. We could wire it like this with 3 in parallel. We could wire it like this with 2 in parallel. We could wire it with 2 sets of bulbs in parallel. We could wire it with the bulbs all in parallel or all in series. So which of these would be best? We know that we need at least 240 ohms of resistance, otherwise the bulbs will burn out. If we only have 2 in series, then even if we only had a single bulb here, there wouldn't be enough resistance. If we have a whole bunch of bulbs in series with each other, then the total resistance of this will be less than the total resistance of one bulb, which means that we'll get too much current going through at least this bulb. So this option is out. What about these two? If we look at the bottom one, we'll be drawing twice as much current as 2 bulbs, right? So the current through each bulb will be the same as if we had simply 2 bulbs in series. 2 bulbs in series have a total resistance of 200 ohms, which is too large, so these bulbs will burn out. We can't wire them all in parallel, otherwise you would get as much current passing through them as if there was only one. So the only options left are this option and having all of the light bulbs in series, right? So just 4 bulbs in series. So we can calculate the resistance of both sets. The effective resistance of 2 bulbs in parallel with each other, and the others in series is going to be 50 ohms for the pair plus 100 ohms for each of the other ones, which is 250 ohms, just barely high enough to prevent the bulbs from burning out. So with 250 ohms, 0.48 amps flow through the bulbs, which is just small enough to prevent them from burning out. And 0.24 amps will flow through each bulb in the parallel pair, because of course this splits in two. No other setup will get currents this close to 0.5 amps without burning out. They'll either be lower than 0.48 amps, or they'll be larger than 0.5 amps. Question 8. Calculate the effective resistance of this circuit. So in order to answer this question, what we need to do is treat these two resistors as one big resistor, and treat these two resistors as one big resistor. And then these two big resistors are simply in parallel with one another, right? So the top resistor pair, 1 and 3, has a total resistance of 1 plus 3, which is 4 ohms, right? So this is one big 4 ohm resistor. The bottom resistor pair is going to be 2 plus 4, which means this is just one big 6 ohm resistor, right? All we need to do is solve the question, is find the effective resistance of two resistors in parallel, one with resistance 4 ohms and one with resistance 6 ohms. That shouldn't be too tough. The total resistance will be 1 over R equals 1 over 4 plus 1 over 6, which is 5 over 12. And so, flipping that over, we have total resistance is 1 over 2.4 ohms. So the total resistance is going to be 2.4. If we have a 4 ohm resistor and a 6 ohm resistor in parallel, we know that the total resistance will have to be less than 4 ohms. So 2.4 seems to check out. Now let's change this circuit just a little bit. I'm going to put a wire through the middle. Calculate the effective resistance of this circuit for question 9. So in this case, we have something a little different, don't we? We can no longer treat this as one big resistor because there's a wire coming out halfway through the resistor, or in fact a little less than halfway through. So in fact, now that we have this wire across here, we have to treat this as one big resistor, right? The one wire across the middle is the same as having a wire connecting the pairs like this, right? So this is how we need to calculate the effective resistance of the circuit. Effective resistance of the left resistor in series with the effective resistance of the right resistor. Make sense? Then these two big resistors are in series with one another, and we can use that to find the effective resistance of the circuit. You might like to guess whether the effective resistance will be larger or smaller than before we put the wire between them. So the left resistor pair, this one over here, has a total resistance given by 1 over R equals 1 over 1 plus 1 over 2. That is 3 over 2 altogether. So the total resistance of this will be 2/3 of an ohm, right? The right resistor pair will have a resistance given by 1 over R equals 1/3 plus 1/4. This gives us 7 over 12. So flipping that upside down for the equation, the total resistance of this pair is 12 over 7 ohms, or about 1.71 ohms. Now what we need to do is find the total resistance of these two resistors in series. And to do that, all we need to do is add them together. So 2/3 plus 12/7 gives a total resistance of 50 over 21 ohms. Or, if we want to represent that as a decimal, about 2.38 ohms. Remember that before we added this wire, we had a resistance of 2.4 ohms. So putting the wire here has slightly decreased the total resistance of this circuit. Question 10. Draw a circuit with an effective resistance of 3.5 ohms using only resistors with a resistance of 1 ohm. Now there are two ways of solving this question. What we need to do is figure out a way of getting that 0.5. It means we're going to need to do resistors in parallel with one another, right? So when two 1 ohm resistors are placed in parallel, the effective resistance of the pair is 0.5 ohms. Place this pair of resistors in series with 3 more, and we have a total resistance of 3.5 ohms. So drawing a diagram of that might look something like this. Now, as I mentioned, there is another way of doing this. If we have two branches of a parallel circuit, and each branch has 7 1 ohm resistors, then it's like having two 7 ohm resistors in parallel with each other. This will have a total resistance of 3.5. We could also do something like have two branches of the parallel circuit with 5 ohms in each for a total resistance of 2.5, and then have that pair of parallel circuits in series with a single 1 ohm resistor. That brings the 2.5 up to 3.5. Anyway, this is the simplest way that we can get the circuit. It uses up the least resistors. So that's the end of the questions. In this section, we've talked about more complex circuits that contain resistors in parallel and resistors in series. We've talked about how to find the total resistance of the circuit by grouping together, close together resistors, and then using that group as one big resistor, which we can then find the resistance of other resistors that are in series or in parallel with it.